All right. I still see some sponsored things on the video stream, but all right. Is your entire IT staff outsourced 20-somethings? Is your cloud environment architected by a thought leader's fever dream? Have you swallowed heaping gallons of the DevOps Kool-Aid only to find out that you're one misconfig away from losing everything? Ochaun Marshall here to invite you to flex seal your CICD pipeline. If you're interested in diving deeper into this topic, my slide deck is hosted at tinysi/fletskill, and also feel free to ask questions during the talk. I've got Discord and Mixer open, so I'll be glancing over from time to time, checking in, see what sort of questions you have for me and feedback. Get this dialogue going. But to introduce myself and who I am and what I do, I code, I teach, I hack. I'm a full-time developer and DevOps engineer. The things that I'm talking to you about today are about implementing security best practices in production-facing systems. This comes from experience of actually trying to do this in the real world. I also have experience explaining how to do things like videos, blogs, and live classes. Not only am I a developer and an instructor, I'm also a full-time offensive security red team consultant. So I've seen organizations who've architected cloud-native web applications well, and I've seen them do not so well. So that's enough about me. Here's the ground that we're going to cover. First, I'll define what a CICD pipeline is so we're all on the same page. And then we'll focus on 4 strategies inspired by the FlexSeal family of products. The beautiful thing about those commercials is the demos. So every concept that I'm going to talk to you about today has its own demo in it. First, we'll cover some foundational knowledge on IAM and S3 bucket policies. Then we'll jump into flex gluing infrastructure together with CloudFormation. Then we'll talk about Node and the horrendous dumpster fire it is and how you can flex tape leaks and broken dependencies in your pipeline. Then we'll follow up with some final tips on just some basic container security. So a CI/CD pipeline is a system that allows integrated versions of the source code to be deployed into production-facing systems. In a perfect world, we get something from repo to production in seconds. In the real world, we either end up with something painfully slow or something that leaks way too much information and way too much data at once. So the focus of this talk is to bake in as much security as we can in the building, testing, and deployment phases of the pipeline without sacrificing efficiency or availability. All right, there is a lot of tooling in this space, like a lot of tooling in this space. So you've got Travis, you've got Jenkins, you have GitLab, and a whole bunch of other players. In this talk, I'll be just keeping it simple and centering it around code pipeline. Why? Because it's a tool I'm most familiar with. Therefore, it is perfect. But no, it's a decent tool because it's relatively easy to set up and it allows you to automate build and deployment processes in AWS. So this process can be as simple as a 2-step deployment, all right? Taking a static website and throw it in an S3 bucket. Or it could be as convoluted as you would like with unit testing, automated deployments to CloudFormation stacks, and even manual approval processes. So, of course, there's a lot of flexibility with this tool. And GCP and Azure, of course, have their own versions of the service. When you get code pipeline, you are given temporary access to a build container that will have the AWS CLI, Bash, and outgoing internet access. The other tools will fit neatly in this, but first we need a more concrete example. So imagine for a second, you're building an online portal, but you decide it's going to be serverless. The client-side application will be deployed to an S3 bucket. All the requests will be handled by Lambda functions grouped into a REST API and defined an API gateway. And user information and user groups will be stored in DynamoDB. Now, each of those Lambdas will access different APIs and other AWS services at different levels of authorization depending on the user. Now, does that sound convoluted? Trust me, you have no idea. But these are the types of applications people are actually building. It's normal to create cloud-native applications that speak to dozens of services. And not only do you have to manage multiple resources and multiple different services, you also have to manage the identity and access management of those services and how they talk to each other as well within the entire tech stack. So in order to figure that out, we need a quick crash course on IAM and AWS. So IAM, or Identity and Access Management, has to do with users or entities acting on a user's behalf. There are hours of content that can go into each element discussed here, but we'll stick to an overview for now. Users and groups are pretty self-explanatory to this audience, so we won't get into that. What we'll focus on is IAM policies and IAM roles. An IAM policy is just a JSON document that specifies what a user can and cannot access. And a role is just a set of one or more policies. So let's start with an example. I'm a user in my company's AWS environment, and I have two roles. I am a developer, and that gives me access to scripts and company source code. And as a consultant, I also have permission to spin up an EC2 instance for cracking passwords. Not all entities are users and groups, however, in AWS. You see the resources, AWS resources, like Code Pipeline, are their own sort of entity. They have roles, and they also have policies attached to them delineating what they can and can't access. So understanding the fundamentals of IAM is important to actually making a functional production system. This is necessary for not only just the sec teams, but the devs to know as well, because by default, AWS services do not talk to each other. Nothing talks to anything, and nothing works. It's ultimate security. So you have to start by opening up little bit by little bit to actually have some functionality and access there. However, if you open up things too much, you can mess up your IAM roles and policies and make your entire environment insecure. Oh, and there's just one more thing, S3 bucket policies. They're like IAM policies, but they're slightly different. So IAM, the focus is sort of egress. What service is communicating with what, and what permissions are involved there. S3 bucket policies are more ingress. You have this attribute called the principal that defines what is allowed to come in and how is it allowed to access resources within the bucket. But more on S3 bucket policies later. Back to IAM. So when you mess up either in IAM or S3 bucket policies, you're just spelling out disaster, and you're opening up yourself to exposure. The Capital One breach wasn't simple, oh, they left an open S3 bucket in the internet. The attacker was able to compromise the web app that was running on an EC2 and was able to navigate through a web application firewall. So once the attacker got onto the underlying system, that was the point where on that EC2, she was able to query what sort of access permissions does this particular EC2 instance have. Oh, I can access over 300 buckets. Let's dump the data and see what's going on there. So if Capital One exercised the principle of least privilege and only gave that EC2 instance access to specific buckets and specific files, then the damage caused by that breach wouldn't have been nearly as significant. So secure use involves using a little bit of flex paste to connect IAM policies with S3 bucket policies. And of course, as promised, demos. So we're going to run through 3 quick demos. One of the AWS policy generator, which will help us write the JSON for both IAM and S3 bucket policies. There's the AWS policy simulator, which does an important role of just simple access permission checking, so we don't have to bash our heads against the CLI or the console. And then there's Parliament, which is an open source tool that allows you to do some linting and some static analysis of policy JSON and figure out when you're opening up things that you really shouldn't be. And we transition to the browser. So this is the IAM policy simulator. Here you can run simulations for pretty much every AWS service. And you can do so as any user in your environment, groups, or roles, unless, of course, your OPSEC team, your security team has locked this down in any way. This service is absolutely free, and I do not mean free as in free now and a $400 charge later. I mean absolutely free to use. You're not spinning up or using any of the resources here. So we jump into roles, and I'm going to demonstrate quick instance of a horribly written S3 role. So a bad S3 demo role involves this built-in policy called the Amazon S3 full access policy. And as you can tell, right, it allows you to do whatever you want in S3. So we scroll down to services, select all the actions, and then just quick run of the simulation. Green means go, right? But green means go for you and any illegitimate user that happens to have access to this role can assume this role, or any entity that's attached to this role. And most of the time, you don't even need this much access. Like, what is describe job and what is describe jobs and get object torrent? You don't, most of the time when you're using S3, your use case is simple. I would like to view a list of files. I'd like to download files. I'd like to upload files. And maybe, depending on permission model and conditions, I would like to delete files every once in a while. So can we run a simulation of a better S3 bucket policy? All right. So here's an example of a secure S3 bucket policy. Not bucket policy, IAM policy. So when we run this simulation, bam, access denied. And this is a good thing because the simulation resource that we've designated here is wildcard or everything. So let's narrow it down and let's run these simulations based on all objects in an S3 bucket, and change the specific bucket actions to a specific bucket. Now, the beautiful thing about this simulator is that you can run simulations on entities that don't even exist so long as you have the ARN. So if something hasn't been deployed yet, or you just want to test out the permission structure, you can do so in the simulator without having to worry about it actually needing to exist. So we run the simulation, and you see the tiny green. We are allowed to list bucket, meaning refer to this bucket by name. We are allowed to put object, meaning you can upload objects, which is a fancy way of AWS saying file. You can upload objects to this bucket, and you can also get object, meaning you can download resources from this bucket. So anyone that has the ability to assume this role only has access to one bucket, has access to all files, hence the star here, but that's okay. It can access all files in this one bucket. If you want to be really granular, you can add slashes and to denote subdirectories. So that's good. But let's say, all right, I really need to open this up to illustrate that action I discussed earlier when we were talking about deleting objects. So let's say this EC2 instance is attached to a web app and users need to delete files, for example. So how do I end up writing the policy? So the beautiful thing about AWS Policy Simulator is that not only can you test existing policies within your environment, you can also create new policies right here. So with here, you can just, it's like any other text editor. You can just write in the policy, and the difference is when we can reset the context and rerun the simulation, you can run it based on this temporary policy that you're working on. So you can draft and you can edit, and you have sort of, it's like coding with a compiler in a way. So S3, delete. Now, we rerun the simulation, and let's see, delete object is allowed, and it has a matching state, and it has one matching statement. Also, for matching statements, you can click for details to find out which statement specifically. Now, if you have a huge policy with a whole bunch of different statements, this part will actually be useful for you. So there you go, the IAM Policy Simulator. But I don't know, writing JSON in curly braces is weird, especially because I'm nervous. I might have missed a quote or a curly brace. This could have been a complete dumpster fire of a demo. So how do we generate policies? How do we generate IAM policies from scratch? There's no excuse, there's no shortcut to knowing what these actions are and what they do. However, if you do know the actions, you can just generate the policy through here, so you don't, and this tool will spit out the JSON automatically. So we're going into an IAM policy. The service that we're specifying is Amazon S3, and we can do the same thing really quickly. So get object, put, delete, and list buckets. And the list bucket, remember, is just being able to refer to the bucket by name and look at its file contents. So for action, and there's a useful hint here for the Amazon resource name. So we can just change that real quick to some bucket, and we can designate that to star, and we just delimitate it to that same thing again. Not that. Delimitate it the same thing again. Now, the reason why I'm adding two statements, one with bucket and one /star, is because you need, if you're opening up, if you have bucket permission, you need to open it up to the bucket specifically. So buckets and objects are separate entities in terms of IAM. If you have actions that refer to both, you need to specify the bucket and the objects within that bucket as separate resources. So we add the statement together and generate the policy. Ta-da, JSON. So back to what I was talking about before, there's also another type of policy called an S3 bucket policy. And those are two options you can use. There are two options you can use to manage access to S3 buckets and files to them. You can use IAM or you can use S3. And I say options in the same way that David Leonard earlier in the presentation said seatbelts and airbags are options. You really should use both in order to delimitate access. So this demo wouldn't be complete if I didn't do a brief exercise in S3 bucket policies. No one cares. So S3 bucket policies. We're going to start with some deny statements. Our goal is with this S3 bucket, let's say it stole payroll and account data. The goal is that no file within this bucket needs to be unencrypted in any way. We need to force encryption access on all files and all objects uploaded to S3. So we're going to do principal star. Now, in an allow action, this could be very dangerous, but this is a deny action. So we're just saying we're denying everybody, and we're denying everybody in certain conditions. So the action to upload files is put object. So we just drop down to here. And then we'll just say for this ARN, and we'll just call this bucket payroll bucket. Because why not? And then we will denote it /star. Because again, this isn't, this action specified isn't on a bucket, it is on objects within that bucket. And so we're specifying, and we're going to say, all right, we're denying all put object operations under these specific conditions. We will deny every unencrypted upload that is possible. So the way you do that is that with you condition null, and then with the S3 X AMZ server-side encryption, and you just set that to true. And you just add that as a condition. Now, this isn't the only statement we need in this, so we'll just continually be using the tool to add more statements. Now we're going to make sure that, hey, it just can't be any encryption. We need to make sure it's AES 256 always. So for that, you do string not equals, and then the same header, AMZ server-side encryption, and then you specify the value to AES 256. Yes, the string is case sensitive, so be careful with that. And you add the statement, and that's good. But we're not complete. So this warning, we can't actually generate the policy because you can't just talk about things that you're denying. Most AWS services are locked down and closed up by default. So you need to specify any condition for allowing. So in this case, what I'm going to do is I'm going to open this bucket up to a principal entity. And instead of being an ARN for S3, we'll just do an IAM. We'll just do a quick IAM ARN. And in this case, we do user / Ochaun, or B. And so we hide this. And in this case, what actions are we allowing? We're just allowing me just a basic file access, download, upload, delete, and list the contents of a single bucket. So get, so delete object, get object, put object, yes, and list bucket. 4 simple actions. So let's say I'm an accountant now. I have access to the payroll bucket, but only simple file access. So we add the statement, and now we can generate the policy. So this policy is a straight S3 bucket policy that you could just copy and paste from here into an S3 bucket, policy, a option in the menu, and it's generated for you. And it's an easy way to write things. All right. And so that's IAM Policy Simulator. That's the AWS Policy Generator. Now we're jumping into the virtual machine. So, quick virtual machine that I spun up. We're going to be previewing a tool called Parliament. And what Parliament is really good for is linting and security analysis of IAM policies. If we jump into what the test file, if we look at our test files, we'll see, all right, hey, this is an S3, this is an IAM policy, but hey, it's opening up the bucket and all objects within that bucket. It allows you to download objects and also to modify and have write access to the put bucket object policy. Now, the simulator nor the generator will tell you why this is bad. This is where this tool comes in. So when we run Parliament, we see the reason why this is bad. It allows privilege escalation. If I have write access to the bucket policy for an S3 bucket and its bucket policy, I can make it do whatever I want. I can open up access even though I wouldn't be. I can open it up to the internet, or I can just take over the bucket, encrypt everything and make it so that no user can access the bucket. So the reason why this policy is bad is privilege escalation. And of course, thanks to Parliament, we were able to see that. We were able to do some static analysis and see that. Now, back over to the slides. We're going to jump into CloudFormation here. And I hate to break it to you, but everything, and I do mean everything, is a loose collection of parts stuck together. So APIs, microservices, libraries, open source, and legacy code. Cloud native applications are just that, glued together pieces of a dozen or so cloud services. Now the question is, how do we tie this stuff together? We could have engineers creating things each in the console by clicking and going through, but the horrible thing about that is who documents what changes are being made and what needs to be changed. Like this, if you're changing an entity in your AWS environment, you could have dozens of different web applications and microservices dependent on that resource. And once you change it and if you change that, you've now reduced the understandability of that one particular resource to one person or one engineer. And so this is just a disaster waiting to happen, in which you're scripting and doing things and gluing things together. This is where CloudFormation comes in. So CloudFormation is a template for blueprinting cloud services. Think of it like a UML diagram, except this document actually helps you make working software. You can pause and deploy, you can push a button and deploy the entire tech stack for an application based on a single JSON file. And you can provision most AWS services, including IAM roles and policies, using CloudFormation templates. You can even provision the entire pipeline for the stack within a CloudFormation template. So if you template your entire tech stack, not only can you just replicate the entire thing easily, you can modify it, you can version control it. So instead of cobbling things together, you get something more streamlined and something more elegant. But what is the actual value that's added here? What's the value for security teams? Well, if your infrastructure is in the code base, you can analyze the code for vulnerabilities before the code is deployed. Now, this demo is using a tool called CFN-NAG. That's CFN_NAG. It looks for patterns in CloudFormation templates so that you can identify insecure infrastructure in the code base before it is automatically deployed. So in a previous version of the portal, which was active development, we were able to scan the CloudFormation template and then have another pair of eyes on various resources, as well as the IAM rules and IAM policies built in within that tech stack. So if you're going to be gluing things together, if you're going to be building, let's flex glue it together. Now, here's a bit of homework for anyone that has Node in their stack. You can use the package manager to audit all your dependencies for vulnerabilities. Alyssa Miller did an excellent keynote earlier in the day when she was talking about 600 vulnerabilities and the official Node package and the official Docker images for that. I'm surprised it's only 600, and you'll see why. You can use simple npm audit to just audit your dependencies and take a look at your entire supply chain if your stack happens to be running Node. And there are other tools that do this, like Sneak and GitHub's dependent spots, but A, this is free, and B, you don't have to install anything extra. So you'll find these tests often produce nothing. But sometimes you will get a laundry list of vulnerabilities. So how do we address this problem? How do we secure our software supply chain in Node? 3 words in the command line. Not every patch will be this easy, but a lot of them are. So some of them, I mean, come on, they have breaking changes and things like that, but a lot of these patches are just 3 lines. So if you do have breaking changes, you may have one engineer in an active development focusing on running through those patches in one afternoon. Or if it's a production, large-scale enterprise app, you could get a couple of people allocated to a week. But a lot of patches, a lot of upgrades, if it's been reported in Node, chances are there is a patch that probably applies it. And there's similar tooling for this is in C#, Java, Go, and many other languages. A lot of that tooling is open source. So big names in this space include the OWASP dependency check, OSS index, and retired.as. So rather than taking the red team to spin up the SAST and DAST tools and throwing them at it, rather than running up Burp Suite and just hammering at the web app, you can eliminate a lot of this easy, low-hanging fruit in the pipeline before the code is even deployed. So fix leaks in your pipeline by just flex taping your dependencies. And here is live deployment. So here's a brief demo of the portal that we discussed at the beginning of the talk. As we go through, we notice that, hey, the build execution failed. And after investigation, we find that all the other services work. We've deployed the CloudFormation stack, the unit test work, the API was deployed correctly. But we notice that there is a moderate level of vulnerability. Now, I don't know about you, but my boss will not let me ship client-side code with cross-site scripting in it. In your environment, however, this may be a high availability system in which you need to focus and concentrate on high or critical issues. So you can set the audit level to there. Not only that, but since this is in the pipeline and this can be expressed as not just ASCII text, but JSON, you can set up an alert to trigger patch management for intervention on the tool. Or you can, in fact, do the NPM audit fix, like we've discussed earlier, and patch these and then patch the dependencies automatically. If certain unit tests pass with the patch applied, then just run it through without any human intervention. So what you do in your environment depends on your tolerance for risks and your processes for vulnerability management. Now we on to the good stuff. So flex sealing containers. So with AWS Code Pipeline, you get a provision container with basic deployment tools and its own sort of tool chain. But they allow you to use your own containers. Now, some of you have custom built Docker or multiple containers in a Kubernetes cluster that aid in building and deployment of your products and services. Now, the world of container hardening is vast and growing, and there is a lot that I can cover, but here are some basic security hygiene 101 tips. One, don't run any more services than are needed. Limit access to orchestration tools, limit access to administrative dashboards, even eliminating some basic tools you would think, oh, this container needs it. If I pop a container, I'm on that machine and it doesn't have curl, that makes my life a whole lot harder in pulling in other tooling in order to pivot to other nodes within the cluster. So least privilege, the principle of least privilege is not just IAM, it's also into what is installed in the container. Two, you have to understand that Docker access is root access. The Docker daemon runs as root in the system. So if a user is added to that Docker group, they can do a quick privilege escalation and get root with just one command line, with one command. And we'll go over that in the demo. Three, make sure that your host system's kernel is patched. So containers is a sort of a misnomer. You don't have that level of isolation that you would have in a VM. So if you need to secure your containers, start at the host. Make sure that the host system's kernel is patched. And if you take sure that you protect the integrity of the host, you also protect you also add some security into the containers that you're using. So here is a demo of a trivial, and I do mean trivial, privilege escalation with Docker permissions. So let's say we popped a user called Quill, and we got access to them. What can we do from here? Well, let's see what group Quill is added to. All right, he has Docker permissions. So let's see if I run this command, and we're root. So that happened fast. So let's break that down a bit. So when you're doing this sort of privilege escalation attack, what you're doing is that you're taking each element of isolation that the container has from the host, and you're just setting it to the host machine. So privilege, access to the host devices, kernel functions, and other functionality. You're just making sure that you're setting the net and IPC to the host, and the volume mount that you see here is just mounting the root directory of the host. So you're opening up, so your goal is pull in the entire file system and open it up to the container. And then appline chroot host is that you run that in the appline container. Now, the best way to prevent this is just to control who is allowed to run Docker in a given system. Now, there is some experimentation with rootless Docker, but that's not production. If you're talking about stable, what's currently out there in the Docker space, make sure you delimitate access and who has access to what. And so you may ask, now, all right, now where's the tool that automates all this work? And I'm sorry, I don't have it. I've shown you tools, tactics, and strategies to help builders and security teams be more effective. But tools don't build the tech. Teams build the tech. And there's no handyman in the can here. None of these tools replace the people that must use them and the communication that needs to take place between the security and between security, operations, and development. So whether you are a builder or you're in InfoSec, you're a plumber. You're either laying down pipes, checking for leaks, or fixing them. So by strengthening the connection between parts, by analyzing your building materials, and by preventing data leaks, you can keep the flow of information going for your organization. Thank you for your time and attention. Didn't see much in the track or chat. I see a taco from Keith Champman, but yeah, if I have to hop off and to give room for the next speaker, feel free to hit me up ask me questions about how for nitty gritty and more details on how I do this. More than willing to help. And yet, by the way, the slide deck, every resource that I'm going to is at tinysi/flexseal. Yep. So, yeah, thank you for your time and attention.